Hi guys, so today we're looking at the lesson interpreting functions. It's going to include function notation, so we got to get used to function notation and function notation when it's included with inequalities. So there's a funny meme, I don't know if you can read it, but the plus sign saying I want to see how things add up in the world. The equal sign says I want to encourage equality, and the minus sign says I just want to make a difference. Super funny, haha. Here's the what, why, and how. So we're going to learn how to use function notation with more than one linear function. Why? Because linear functions are everywhere, and function notation will be something that you will see in calculus. Okay? So how do you know if you accomplished today's what? When you can find when f of x is greater than 0 when I give you this function 3 halves x minus 3. So here it says to answer the following using the graph. Okay, so notice we have function f and we have function g down here. So we have f and g. Okay, one of them's a linear function going up, the other one's a linear function going down. So one of them has a positive slope, the other has a negative slope. They do intersect somewhere. Okay, where they intersect is where they are equal. That's the only place where they're equal, is right there at 2, 1. That is where f of x equals g of x. Okay, on each side of that equal, where they're equal, on the left side and on the right side, one is above the other. Okay, so let's talk about that. Let's look at some examples. So the first thing is to find f of 5. So we're going to look at my line f, which is right here, and we're going to go to 5, which this is my x value. Okay, so basically this is saying give me the y value when your x value is 5 for the line f. So I'm going to go 1, 2, 3, 4, 5, and then I'm going to go to the line f, which is down here. So that means that f of 5 is negative 1. Okay, so that means the answer to this is negative 1. The answer isn't 5 comma negative 1. F of 5 equals negative 1. That is the answer. Okay, so don't write the coordinate. You're only right. It's just saying, it's basically asking what is the y value when the x value is 5. So g of 5. So now we're going to look at the line g. So we still have 5 here. This vertical line here is at 5. But for g, we're going to be at 1, 2, 3, 4. So g of 5 is 4. Now notice, g is above f. G is above f for all this entire section. So it's asking when is f of x equal to g of x. So whenever it's when, right, you're looking at your x value. It's just asking what is the x value when they're equal. Okay, so we're looking at the x-axis. So they're equal right there, equal right here. So it's going to be right here at 2. Okay, so the answer would be x equals 2. Because that is where they're equal. That's where they intersect. That is the input where they intersect, is at x equals 2. Now here's the hard part. Okay, when is f of x greater than g of x? So it's saying, it's basically asking when is my f line above the g line. So notice, f is way up here, and g is way down here. So f is greater than g. It's greater than g. F is still greater than g. It's always greater than g until they're equal. Once they're equal, f goes underneath g when we continue to the right as x increases. So when we're way over here at negative infinity, f is going to be above g. Then as we move to the right, they're approaching each other, approaching each other, approaching each other. Now they're equal. And then as soon as we go to the other side of this x equals 2, f is now below the function g. So now from all of this on, f is less than g. So we want to know when is f greater than g? Well, it's everything over here. Okay, now we're going to look at what's called interval notation. So interval notation, you always want, you're going to use brackets or parentheses. Okay, if you're including it, you use a bracket. If you're not including it, it's going to be a parenthesis. So we got to go least to greatest. So the least x value is way over here, is negative infinity. And as we move to the right, we go all the way to x equals 2. So all of this is what we want because f will be greater than g. So we're going to say from negative infinity, see how my line is above? That's why the arrows are going down. And here, it's below. That's why the arrows are pointing up. So we want that section. So we're going to say negative infinity to 2. Now, the thing is with infinity, you're always going to use a parenthesis because you can't include infinity because you'll never get there. So you would use a parenthesis and not a bracket. And the reason why we used a parenthesis on 2 is because there's no equals to here. If there was a greater than or equals to, then this would have been a bracket. Okay, so here's when is f less than g, but less than or equal to. So here's where you're going to see a bracket. So like I stated before, all of this, all these x values back here include y values such that they're greater than g. But then as you move over here, f is less than g. It's underneath it. So we're talking about x values. So we want to know, is it going to be to the left of 2 or to the right of 2? It's always the x value of where they intersect. It's either the left or the right. In this case, it's going to be to the right. So we're going to include 2. So it's all of these x values, all of these. So that's going to be from 2 all the way to infinity. And you can never include infinity, so that will be a parenthesis, as opposed to you can include 2, so it's going to be a bracket because f is less than g. Less than g. Okay. Now domain and range. Remember, domain is input. Like what x values are you allowed to have? Well, you're either given the equation, and you could see if there's any limitations. Like if there's a square root, then you can't put in a negative. Or if you have a denominator, you can't have it equal 0. But in this case, it's linear, and we only have the picture. So what you do is you look at the picture and think about how wide it could go. So this is going to keep going. It's going to keep going to the left. It's also going to keep going to the right. So f will always get wider and wider. So really, the domain is all real numbers. Okay, there are no restrictions for what you can input. So that's how you put all real numbers, from negative infinity to infinity. And yes, it has to start from negative infinity because that's the smaller number. Domain of g. Well, same thing. G is, yeah, it's going down, but it's still getting wider. And it's going to the right. It's still getting wider. I mean, it's moving at an angle, so it's going to get to infinity. It's going to get to negative infinity. So that's all real numbers. And so for the most part, unless it's a horizontal line, all linear functions will have a domain that's all real numbers. Okay, horizontal lines, well, actually, what I meant to say is a vertical line. But remember, a vertical line is not a function. So that one would have a limited domain. But a horizontal line, which is a function, it still has no restrictions. It's from negative infinity to infinity. Okay, now it's asking for the range of f. That means how high and how low will it go? Well, it's still going to go up forever, and it's going to go down forever, just like it's going left forever and it's going right forever. So the domain here is negative infinity to infinity. Okay, so that's for all linear functions except for horizontal lines. Okay, because those don't go up and down forever because they're flat. Okay, they stay constant. That's why they're called constant functions. Okay, so another example, we want to find f of negative 2. So let's go to negative 2, and we're going to go to the function f. So here's negative 2. X equals negative 2 right here. Okay, actually, I'm going to try something. Okay, so I could actually use a pen here. That's what I wanted to do. Okay, so we're going to go to negative 2, which is right here. Okay, there's my negative 2. And I want to know what is the y value on f. Well, here's f right here. That's f. So what is the y value here? Well, that's going to be -1. Let's do control, let's escape. Okay. So that's -1. G of -4. So I'm going to go to -1, 2, 3, 4. And I want to get to G, which is up here. So there's my -4. And I'm going to go to my G line because I want to know G of -4. And that's 1, 2, 3. That's at 3. So remember, you don't write the coordinate value there for this function notation. You write in what the y value is, the output value. Now here, when you see the question when it starts with when always refers to the horizontal axis. That is the x-axis. Because usually it's kind of like the time axis. That's the t. So it's when is only the x value. So when do they meet? They meet right here. They say, hey, nice to meet you. But it's the x value, so x is 2 right there. Yes, it's 2, -1, but we want the x value. So it's x equals 2. Now it's asking when is f greater than g. So when is my f line above the g line? Okay, so if you look here, f is below the g line. Below, 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 below. Then they meet. They say, how you doing? Now f changes, and now f is above g, so greater than g. So remember, we always want our interval notation. We always want to go from left to right, from least to greatest. So the smallest value this occurs is going to be just to the right of 2 because we don't have an equals to. So it's going to be basically from 2 to infinity, but we're talking about x values. So from 2 to infinity, f will always be above g, but we don't include 2, so we use parentheses. Okay, if that was an equals to here, we would have a bracket. So now we want to know when is f underneath g. Well, it's all of this. It's all of this value. Everything from here on, f is underneath g. So we want left to right though. So the smallest x value that this will occur at is at -infinity. And then it goes all the way to 2. And we're going to include 2 because it's okay to include an equals to. So we're going to have a bracket on 2. You cannot say 2 to -infinity. That is incorrect. It's always least to greatest. Okay, domain of f, how wide will it go? It's going to get wide forever, all real numbers. Okay, what is the domain of g? So how wide will g get? Well, even though it's going angularly, it's still going to the left forever, and it's going to the right forever. Okay, what is the range of f? Well, that means how high and how low will f go? Well, f is never going to get bigger than -1. It's never going to get smaller than -1. Because remember, the range is the y value. Okay, so it's not going to go above this. It's not going to go below it. So it stays at -1. So we'll just write it as -1, only including -1. And we'll just put brackets around it. Okay, so take some time. Think about these. If you have the notes open, annotator, why don't you try those? Try going over those. Take some time. Okay, so pause it, pause the video, do the work, and then move on. Okay, but I'm going to go over it right now. So we want f of 0. So here's x equals 0, and my f line is up there. So that's going to be right there at 3. So that equals 3. g of negative 3, so I'm going to go to x equals negative 3 and go to the g line. To get there, I have to go down 2. So that's the reason why g of negative 3 is negative 2. When are they equal? Well, they'll never cross, right? They're parallel lines. There's no solution there. You can put empty set or no solution. When is f greater than or equal to g? Well, it's always above g, always. So it's all real numbers. When is f underneath g? Well, if these are horizontal lines, they'll never cross. So we'll say no solution. What is the domain of f? Well, how wide will it go, right? That's the x values. What x values are you allowed to input in? Well, it's going left and right forever, so all real numbers. And then domain of g is the same thing. And here it says, what is the range of f? Well, how high and low will it go? Well, it's only going to stay right here at 3. It's not going to go above 3 or below 3. So it's just going to be 3 because it's a horizontal line. Okay, that's it. Remember, if you guys have questions, let me know. But I hope you enjoyed it.